morning. I have here a new subject regarding Physics 2. Okay, and our new topic today is related to direct current circuits. Okay, so this is we are involving in electricity for some circuits. Now I will discuss to you regarding the direct current circuits. Actually, there are two types of direct current circuits. First is the here resistors in series, and the second one is resistors in parallel, but I will tackle that one later, guys. First I will discuss to you the resistors in series connection. Okay, so series connection. So I have here a diagram showing series connection. Okay, composed of resistors and source. So this, guys, is the source or the battery. Okay, and this is the conductors. Okay, the electrical wires. Okay, conductors. So in this diagram, I am showing you some three resistors in series. R1, first resistor. R2 is the second resistor. R3, third resistors. But also you can add some more if you want. But here I am showing you at least three resistors. Okay, three resistors. And of course, guys, once this connection is completed, it's already connected in the battery or source, and the resistor, there is a current flow, okay, going to the three elements. The elements here are the resistors. Okay, so as we studied before regarding some electricity, as we all know from Ohm's law, okay, the basic formula for Ohm's law is, okay, basic principles. Yes. Okay. The basic principle of Ohm's law. Okay. Okay. That the voltage is equal to the product of the current and the resistance. Okay, I R. Okay, I means the current in terms of amperes. Okay, R is the resistance in terms of ohms. So this is the basic formula for Ohm's law. B is equal to IR, or voltage is equal to the product of resistance and ampere or current. Okay, but for this particular connection, guys, since we are discussing about series, the properties for this particular connections is the current flowing around these elements is equal to, okay, 1, I have here the current. Okay, the current flowing in a series circuits is constant. Okay, the current excuse me, guys, flowing in a series circuit is constant. Okay, constant. So current, okay, I total, or the total current flowing in the series circuit is equal to constant. meaning I1, okay, is equal to I2, the current flowing in the R1 resistance is equal to the current flowing in the second resistance, okay, second resistor, also equal to the current flowing in the third resistors, okay, guys, it's a constant, ha. For series connection, take note guys, for series circuit connection, the current flowing in this circuit is equal to constant, okay. Now next, the second property for this resistors in series is the total resistance, okay, total resistance for resistance connected in series is equal to RT, means the total resistance is equal to summation of all the resistance, summations of all the resistors, okay, so to R1 plus R2, okay, this one guys, plus R3, and so on and so forth, okay, plus Rn, okay. So you have to remember this guys, okay, that the total resistance for resistance connected in series is equal to the summation of all the resistance, okay. So RT is equal to R1 plus R2 plus R3 and so on. Now third one is for series connection, the total voltage, okay, the total voltage across the series resistance, okay, the total voltage across the series resistance, okay, across the series resistance is equal to total voltage is equal to the summation of all the voltage of all the resistance voltage, okay, summation. So B1, okay, voltage drop for this R1 resistor plus the voltage for the second resistor B2 plus the voltage of this R3 resistor, okay, plus and so on and so forth, okay. So take note for this expression guys, because we will use this expression in solving some word problem related to DC circuits where resistors are in series connections, okay. Ohm's law, ha, we need to apply the basic principle of Ohm's law, okay. And to calculate for the power of the resistance, we have P power is equal to the product of volts times current, or PBI, okay, or power is equal to, if we substitute the value of B based on this Ohm's law, so B is equal to IR, okay, IR times I is equal to power is equal to I squared. I times I is I squared times the resistance. Okay. So this basic formula, guys, we need to remember. For power, this one, volts times the amperes, and also in terms of current and resistance, this will be power P is equal to I squared times R. Okay, where R is in resistance in ohms, I is in terms of amperes, okay, and power is in terms of watts. Voltage or volts is in terms of volts, okay, or V. Okay, guys. So this is our first topic regarding for the direct current circuits and the resistors in series. Now, later, guys, I will discuss you the second topic, with this resistors which is connected in parallel. Okay. Hi, guys. We're back. Okay. So as I mentioned earlier, I will discuss to you second topic related to the DC circuits. Our second topic is resistors in parallel connection. Okay. So I have here a diagram, guys, related to the parallel circuits. This area, okay, is the source or the uh, battery. Okay. And these three connections are in parallel. Okay. The first resistor, second resistor, and the third resistor. Okay. Once it is connected in a source, these resistors, there will be a current flow going these connections, I total, or the total current. Okay. Once it is entering for every junction, total current will be distributed to the three resistors. Okay. So there will be a current passing this resistor. Okay. So it will be I1. Okay. The other one will pass here. Okay. I second current, I2. And this one also, guys, will be a current passing this third resistor. It is I3. Okay. And going to the source. Okay. So knowing this diagram, the voltage drop across each resistor is equal to, okay, is equal to its resistance. Okay. The voltage across its resistance is equal to voltage for its resistors. Okay. So meaning to say, total voltage, okay, is equal to the voltage for this one, B1, is equal to the voltage for the second resistors, okay, is equal to the voltage the third resistor. Okay. So this is the first property on how to calculate the total voltage for each resistors. In every resistor, the voltage drop is equal to each other. Okay. So the voltage drop across its resistance, okay, across its resistance is constant. Okay, is constant. And equal, and is equal to the total equal to the total potential Okay, total potential. Let me write here, guys. Total potential drop of the source. Okay. The voltage drop across its resistance is constant and is equal to the total potential drop of the source. Total potential drop of the source. So meaning to say, the total voltage for parallel series is equal to the voltage drop across for resistor 1 is equal to voltage drop across the resistor 2, and it's also equal to voltage drop across the resistance 3. Okay, and so on. Okay. So take note this expression, guys, on how to calculate total voltage drop or the voltage drop across its resistance. Okay. Now the second properties that we have to remember for this particular parallel connections is that the total current, okay, the total current is the sum, okay, is the sum of the current through its resistor, okay, through its resistor. Okay, so total current IT is equal to the sum of the current through its resistor. Okay, so I1, first current in the first resistor, plus the second current under second resistor, okay, I2, plus the third current under resistor 3 or R3. Okay, and so on. Okay, so take note this expression, guys. For parallel connection, the total current is the sum of its current for every resistors. Okay, and the third one is total resistance. Okay, the total resistance for these circuits is equal to the reciprocal of resistor in series. Okay, what we have learned for resistors in series is the total resistance is equal to R1 plus R2 plus R3, right? Summation of all the resistors for series connection. But here, in parallel connection, all the resistors are reciprocal of the series connection. Okay, so the total resistance for parallel resistance connection for parallel resistance connection for parallel resistance connection is, okay, will be 1 over RT, means total resistance, is equal to 1 over R1 reciprocal, okay, 1 over R1 first resistor, plus 1 over R2, okay, plus 1 over R3, and so on and so forth. It depends how many resistors connected in parallel. Okay, so guys, please take note this expression, okay, in solving the total resistance of the circuit if the connections is in parallel. Okay, so these are the basic properties on how to solve for the total voltage or voltage drop across its resistance for parallel connection, where B1 is equal to B2 is equal to B3, okay, which is also equal to the total source. And total current flowing in this parallel circuit is the summation of all the current in every resistors, okay. And last thing is the total resistance of the circuit. It is just only as a reciprocal of the series resistors, okay, but it's a summation for all the resistance. So 1 over RT is like this, guys, 1 over R1 plus 1 over R2, 1 over R3, okay. So I hope, guys, you understand our topics regarding direct current circuits, especially for series connections and parallel connections. So again, guys, I hope you understand our discussion, and I'm expecting also that the students who are studying under P62 get some idea regarding this DC circuits. Okay, and kindly share, like, and subscribe our channel para mas ma-notify pa kayo sa mga future videos natin regarding some physics. Okay, so again, thank you for watching, and have a nice day.